What's poppin', dogs? Mr. Allen here. We're about to solve this dope rational equation here for x, and we're going to list any domain restrictions. Now, with solving rational equations, I got to get a common denominator. So let's see here. No factoring involved with this one when I'm going to find my common denominator, right? I can't factor anything here. But let's look at this in two pieces, right? I've got 6, 2, and 3 for my numbers, right? It's all multiplication that's occurring in any of my denominators. So 6, 2, and 3. What's my LCD of those numbers? Well, 2 and 3 can both go into 6, so 6 is my number for this LCD. What about those x's? Well, I need an x in each one of these, so 6x is going to be my LCD. All right, now for this one, I'm going to get common denominators throughout the entire problem, then work with my numerators, all right? There's a couple processes you can do to solve rational equations. That's the one I'm going to use for this video. All right, so let's see here. What would make this denominator into 6x? I got to multiply by 3. So I'm going to multiply this guy by 3 down here, but whatever I do to my denominator, I got to do up in that numerator as well. All right, this one doesn't need anything done. It already is the LCD of 6x. Yes. All right, how about this one here? Well, it looks like it needs to both be multiplied by 2, numerator and denominator, but it also needs an x, right? If I want this to be 6x, it needs to be multiplied by 2x. Beautiful, wonderful, fantastic. Now, before I forget, let's get our domain restrictions. What is x not allowed to equal? Well, it's about what would make my denominator 0, because that causes me to divide by 0, which is undefined, right? So 0 would make my denominator 0. So 0 is my only domain restriction. All right, lovely, fantastic, awesome. Let us continue. All right, first guy here doesn't change. X plus 4 over 6x. Minus 5 times 3 is going to be 15 over 6x equals 2x times 4 is going to give me 8x over 6x. Now, look at this. I've got the same denominator throughout. So if my denominators are equal, would it make sense that we could just work with my numerators, figure out what makes those equal, and then my equation, both sides of my equation are equal? Yes, you are correct. So let's rewrite this as x plus 4 minus 15 equals 8x. Beautiful, wonderful, and dope. All right. Now, let's combine some like terms. I got 4 and I got negative 15. So that's going to give me x minus 11. Yep, 11 equals 8x. Now I'm going to solve, let's see here. I got to get x by itself, right? So how about I subtract x onto the other side? Oftentimes, I do enjoy x on the left-hand side, pretty much always. But hey, man, it made sense here just to move it to the right-hand side. Less steps, less time, you know, saving time, saving money. That ain't funny. All right. So now I'm going to divide by 7 on both sides. And yes, this is a terrible, ugly, negative 11 over 7. That's awful. But it's okay. It is the answer. All right. If you were to plug that in, you'd get both sides equal to each other. Great thing is it's not my domain restriction, right? If I got x equals 0 here, I'd have to cross that bad boy out and say, hey, it's extraneous. No solution at all. But it doesn't equal or match my domain restriction, so we're good to go. Cha-ching. That's it. That's awesome. That's dope. And I will see you dogs later.